All right, welcome to part 2 in my series of building an OpenGL game engine in visualbasic.net. This one's going to be pretty short since most of the code we need is already written from the last video. If you haven't watched that video yet, I suggest you stop this one right now and click on the link above and watch that video first. Otherwise, let's kind of jump right into it. Before I get into the code though, I just want to talk a little bit conceptually about what we're doing. Most games aim to deliver 60 frames per second. It's not a hard and fast rule. Your game frame rate will vary based on what you need it to do and your user's hardware. In GPU land, we often refer to this as the target frame rate. This is the frame rate that you want your game to run at, but your user's hardware limitations may prevent you from hitting your target. And depending on your game, it's not going to matter. Your users probably aren't going to notice if you're only rendering 59 frames per second or even 40, or a game can look just great even rendering only at 30 frames per second. But your target is 60 or whatever your target is. If you're targeting 60 frame rates per second, this means that you have about 16.6 milliseconds to render your image. How you decide to render your image, that's completely up to you. You can do it completely in OpenGL, or if you're like me, you can do a little bit in the CPU and a little bit in the GPU. I did this in my game because when I first started, I didn't know anything about OpenGL about 3 months ago. And I was rendering the background image, and the background of the image, there was a background and a foreground, and it was running great on my computer. It was taking about 7 milliseconds to do everything. And I went to test it on someone else's computer, and I went from 7 milliseconds to render a frame to around 20 milliseconds to render a frame, totally missing that 16.6 millisecond goal, and it was looking terrible, and so I realized I needed to do something about it, and so that's when I decided to pursue doing my game in OpenGL. And OpenGL fixed the problem. That my background frame rendering on every computer went down to almost nothing, and now the game runs just smooth on my computer and every other computer I've tested it on. I render the games using bitmaps just because that's what I knew how to do. So I just changed it so the background is rendered on the GPU and the foreground is rendered on the CPU, and then we just merge those two images together. And it works just fine in my game. And probably in the next video, we'll start going into how to actually render things completely in OpenGL, because that's going to be more efficient, and it's actually going to give you a faster load times. But for me, let's take a look. These are 4 frames from my actual game. And we can take a look at the whole frame here. The green area here is just translucency. So I clear it, make it all translucent, and then I draw. There's a star system there being drawn. There's a little game menu, or game window, and a game menu. And then here is just some debug information that I've been drawing on the screen. And you can see how long each one of these steps. These are all the GPU steps. So these are all the different things the GPU is doing. As you can see here, I've got the background layer taking 1.47 milliseconds, and that's great. That's because I'm doing it totally in OpenGL. I'm no longer drawing the background layer in system.drawing graphics. That was taking me, because there's so many pixels, such a large image to draw. That was taking, like I said, it was taking my computer, I think around 7 milliseconds. This one step was taking around 7 milliseconds, and then on other people's computers it was taking 20 milliseconds. So we totally fixed that, and it works great on every computer that I've tested. And so these are all the other things that my GPU is doing. Rendering menus, drawing images, creating animations. And so we'll go into more of that stuff, how to do all that stuff later. But so there's my 4 frames. Let's kind of jump into the code here. The first thing we're going to do is we're just going to create a queue for the image. And so now in my game, this is how I control the frame rate. So I've got my code and how I do multi-threading. And so I've mentioned before that multi-threading in OpenGL is a touchy subject. You can do it, but I've had some luck and some not luck, and so I've just kind of avoided trying to do multi-threaded on the GPU. but I can do multi-threading in the CPU just fine. And so I generate all the game's frames, and then I put them into a queue, and then in my refresh, so I set the target frequency to 0. So my goal is, hey, if there's an image, if there's a frame to render, render it immediately. And then I use a blocking queue for that, and we can go into that later. But in mine, I use a blocking queue, so if there's nothing in the queue, the game just sits and waits until the next frame is rendered. And so that's what gives you your push and pull on your frame rate size. And so once I unleash my game, I can get, on my computer, I can get 120, 150 frames per second. It's really fast. And that's all rendering the foreground on the CPU and the background on the GPU. Works great. So I'm going with that for right now, although as I get better at this GL stuff, I'm going to slowly transition all of my graphic rendering over to OpenGL. So we go ahead and queue these 4 frames from my game. So we're going to put them all into the queue. And now we're going to go into the render frame function. So here before, we were checking the keyboards. I was just doing the offset on the background. We're going to start a new frame, which clears out the existing buffer. We're going to render the background image, which essentially is just going to say Nora render, which is our 3x3 image, and then we're scaling it right now times 3, and so that way you only see one full image on the screen at the beginning before you scroll around. And really, this is really the key thing here. We're going to bind it, so that puts that first one, and we're going to render it, which puts it on the screen. And then we're going to go ahead and go to the frame buffer. We're going to dequeue the first image off the frame buffer. We're going to render that frame, and then just to keep the game going, we're going to re-enqueue that same image. So that's just for our testing, so that we just keep getting the image constantly, going down that list. So let's jump into this guy. So in this render frame, we're going to use a separate texture. So we've got the background texture, and now we're going to have a separate texture for the foreground texture. And we're just going to keep updating that same texture over and over again, but with a new image each frame. And so we pass in the new frame. The first thing it's going to check to see is whether or not we've done this yet. And if this is -1, that means we haven't done this yet. And so it's going to call load texture to load the first texture in. And then it's going to bind it to say, hey, this is the texture we're working with. And then it's going to do a normal render instead of a Nora render, since our game frame doesn't need to infinitely scroll. So we're just going to do a normal render. And a normal render, of course, a normal render is we're going to use quads, and essentially we're doing 0, 0, 0, 1, 1, 0, all those. So essentially we're doing the whole image for the text coordinates, and then for the image coordinate, for the the vertex coordinates, which is the monitor screen, we're going to do 1, 1 there as well. So we're saying, hey, take this whole image and display it on the whole image. And so that's what a normal render does. Then we're going to call flush, which probably controversial in the OpenGL land. I know I'm a little nervous about memory usage and stuff, and so I have a tendency to call it. My understanding is that the swap buffer command also calls flush, so theoretically you don't need to call it directly. So that's all there is to it. I said this is going to be really easy. We're adding these 4 frames to a buffer, and we're rendering that to the screen. Let's see how that all looks. So as you can see, it's shifting between those 4 images over and over and over again. And so that's why we've got this little movements here. And you can kind of see a little bit of the animation from the sun there. And we still got our scrolling background, which we can infinitely scroll. So the background is moving, but the foreground is not. And so that's how I achieved my game. And really at this point, you're ready to go. I mean, other than having to create your game and probably deal with input from the user outside of pressing these 4 keys. But this is everything that you need to do in order to have a successful game rendering in OpenGL. You don't have to render the rest of the graphics in OpenGL. It's okay to render the graphics in system.drawing. Copy, trim over. So if you know how to use system.drawing, and now you know how to use OpenGL, there's not much more to it than this. for the basics. Yeah, so there you go. In future videos, we're going to start showing you how to actually render the drawings, the images in OpenGL, and we'll also start going into handling user input and mouse clicks and calculating locations on the screen, because that's going to get a little complicated when they start clicking and when they start resizing. So you have to like deal with the current size of the screen to calculate where the click is. But we'll get into all that later. Yeah, that's all there is to this. All right, enjoy.